Beyond the flickering lights of our solar system lies a realm of mystery. Uncharted worlds orbiting distant stars. Imagine a planet where storms rage with electric fury beneath twin moons, where endless oceans cradle life more diverse than anything on Earth. These aren't the musings of science fiction. These are exoplanets. And here's the question that changes everything. Could one of these worlds be not just livable, but better than Earth? What if the perfect home is out there, waiting for us to find it? And what would it mean for humanity to step onto a world that feels like paradise, but isn't ours? Let's journey into the unknown and uncover the secrets of these distant, inspiring worlds. First up, what exactly is an exoplanet? It's simple: any planet outside our own solar system. Just like Earth or Mars, exoplanets orbit a host star. Only that star is not our sun. Early on, we thought other stars might have planets, but it wasn't confirmed until the 1990s. Back then, astronomers discovered the first exoplanet circling a dead neutron star, a pulsar, in 1992, and soon after, the first around a sun-like star, the famous hot Jupiter, 51 Pegasi b, discovered in 1995. Since then, planet-hunting telescopes have exploded our tally. Today, we've confirmed over 5,800 exoplanets, and that's just the ones we know about. NASA even notes that there are likely more planets than stars in our galaxy. Now, how do scientists find these exoplanets? The main trick is watching stars for telltale wobbles or tiny dips in brightness. For example, NASA's Kepler Space Telescope stared at about 150,000 stars and noticed the periodic dimming when a planet crossed in front of its star. By analyzing that light curve, Kepler confirmed over 2,300 planets. Other methods include measuring the star's motion as planets tug on it, and occasionally even direct imaging. New missions like TESS continue the hunt. Hundreds of new worlds are being found every year, but among them, one stands out like a beacon in the dark: the TRAPPIST-1 system. Speaking of TRAPPIST-1, let's talk habitability. We often wonder if these alien worlds could support life. A key concept is the habitable zone, sometimes called the Goldilocks Zone. It's the range around a star where conditions are just right for liquid water to exist on a planet's surface. Too close to the star and it's boiling hot. Too far and it's a frozen wasteland. On top of distance, the planet's atmosphere and composition matter. NASA defines the habitable zone as the distance where liquid water could exist on orbiting planet surfaces. Because all life on Earth needs water, so it's our best guess for life elsewhere. Now, what do you need for life? Right distance from star in the habitable zone, liquid water possible. Stable star, not too many flares. Red dwarfs like TRAPPIST-1 can flare up, challenging life. Rocky planet with atmosphere. A world with an atmosphere could regulate temperature and maybe provide breathable gases. NASA recently found the first evidence of an atmosphere around a rocky planet, 55 Cancri e, although it's a magma world. Energy sources, sunlight or maybe geothermal energy, even subsurface oceans, like Europa, could host life without sunshine. Time. A planet needs enough stability over billions of years for life to emerge. If all these align, we've got what we call a potentially habitable world. Think of it like baking a cake. You need the right ingredients in the right amounts to nail life's recipe. Now, let's spotlight some cool exoplanets discovered so far. The TRAPPIST-1 system. As I hinted, this ultra-cool red dwarf has 7 rocky planets, all about Earth size. 3 of them orbit in the habitable zone, potentially with liquid water. Imagine sunsets with multiple tiny suns on the horizon. Proxima Centauri b, the closest known exoplanet, only about 4.2 light-years away. It's a bit more massive than Earth and orbits its red dwarf in roughly 11 days. It sits in its star's habitable zone, but the star's flares might strip its atmosphere. Still, if it has protective magnetic fields, it could be a prime candidate for life. K2-18b, a sub-Neptune, about 8.6 times Earth's mass and 120 light-years away. It orbits in the habitable zone and has water vapor in its atmosphere. Even more thrilling, James Webb Telescope found methane, carbon dioxide, and possibly dimethyl sulfide, a potential biosignature, because on Earth it's produced by marine life. 55 Cancri e, a super-Earth, about 2 times Earth's diameter, orbiting so close to a sun-like star that its day side is liquid magma. James Webb Telescope observations hinted at an atmosphere rich in carbon dioxide or carbon monoxide on this lava world, the first hint of any rocky planet's atmosphere outside our solar system. TOI 700d, discovered by TESS in 2020, about Earth size, orbiting an M-dwarf 100 light-years away. It's TESS's first Earth-size, habitable zone find. If it has water and an atmosphere, it could be a true ocean world. Each of these examples adds a piece to the puzzle. Some raise hope. Others remind us how diverse worlds can be. How are we actually searching for life on these distant worlds? Scientists hunt for biosignatures, molecules that life might produce. For example, oxygen plus methane together could hint at biological processes, though geology can also make these gases, so it's tricky. Using powerful telescopes, scientists study exoplanet atmospheres during transits, when starlight filters through their skies, and eclipses, when the planet slips behind its star, revealing subtle chemical fingerprints hidden in the light. The James Webb Space Telescope, a game changer. It's already identified molecules on exoplanets like K2-18b and 55 Cancri e. James Webb sensitivity means we might soon detect Earth-like signals, if an exoplanet is favorable. We haven't confirmed extraterrestrial life yet. All of this is preliminary clues and possibilities. The universe is vast, and these planets are far away. Even the nearest is over 4 light-years, about 25 trillion miles. But every discovery brings us closer. As NASA says, we know there are more planets than stars, and each one is a chance for life. Billions of worlds, billions of chances. So let's sum up. We started by imagining a sunset on an alien world, and discovered those sunsets could be real. Exoplanets are out there by the thousands, and some lie in their star's habitable zone. We learned the Goldilocks Zone is key for liquid water and life as we know it, and that scientists use powerful telescopes like Kepler, TESS, James Webb to find and study these planets. We saw some star examples. In many ways, we're only scratching the surface, but with every discovery, we're closer to answering the ultimate question. Are we alone in the universe?
The universe is vast, and the mysteries we've uncovered, they're just the beginning. But here's something to think about. What really happens when you cross the point of no return? Is it the end or a new beginning? Join us next time on CuriUs, where we'll dive deeper, darker, and stranger into the unknown. Hit subscribe, and let's explore the unimaginable together. Thanks for watching, and we'll see you in the next adventure.